Hi, today we're going to be talking about undefined and simplifying rational expressions. For problem number 1 on the use what you know, for each of the following, find all possible values for x for which there is no value for the expression. Basically, that means if you substitute a number for x, which number for x for problem A would cause a problem where you could not figure out the value for the fraction. So we can sit here and actually try to plug in numbers. Maybe we'll let x be 3. If x is 3 and I fill in a 3 for all the x's in problem A, I would get 3 plus 3 over 3 minus 4. And it gave me a value of -6. Now the value could be a positive, a negative, a fraction, a whole number, integer. So as long as it gives me a value, it's okay. So let me say let x equal 4. So if I plug in x equals 4, I get 4 plus 3 over 4 minus 4. And I get this error message, and it's saying an error divide by 0. So there's a problem with the number 4 being plugged in. That leads you to an error. So what's wrong with the 4 for x? Well, if I put in a 4 for x, if you notice, you have a denominator of 0. That's bad in a fraction. You cannot have a 0 denominator. Any other x will be fine except for when x is 0. So if I really want to figure out what values would make this have a problem with it, all I really need to know is when the denominator equals 0. So I just type in I just write x minus 4 equals 0, and I just solve that little mini equation. And there's my answer 4 that I got a problem with when I try to type it in myself. So problem B, I can sit here and also try to keep on guessing x's, or I can just remember that when the denominator equals 0, there's going to be a problem. The numerator can be 0. You can have a 0 numerator. You just can't have a 0 denominator. So when x squared minus 2x minus 15 equals 0, it will be undefined. All right, and this concept you did back in Algebra 1. All right, so now this type of equation is a quadratic, and you learned last unit how to solve quadratics. You need to factor, or you can even use any other method. So when x is 5 or -3, and I could actually try to fill them in, if I plugged in a 5 for all the x's or I plugged in a -3 for all the x's, I would not get a value for that fraction because that would give you a 0 denominator, and that's not acceptable. So these are when the fraction is undefined. Okay, the next thing we're going to do today, and this is again just warm up, is to talk about simplifying a rational expression. So we're going to first start off with basically solving basic fractions. Problem 2a. I know for a fact that you can simplify on your calculator. So if you really wanted to simplify problem 2a on your, you could use your calculator by simply typing in the fraction, and then it'll reduce for you. But what I want you to do is understand why this is happening. So the answer will be 5/6. What we mean by simplifying is to divide out common factors in the numerator and the denominator. So 20 and 24 have a bunch of pair of factors that make 20 and 24. But I'm going to just show you what's happening. 20 and 24 both share a common factor of 4. So I can write 20 as 4 times 5, and I can write 24 as 4 times 6, and then what happens is the common factors of 4 divide out, and that's why you get a final answer of 5/6. So that's the idea that is really going to be there for all the problems when you're simplifying, even the ones that look really complicated, is you're trying to divide out common factors. So problem B, what are the common factors? Well, 6 and 3 share a common factor. 3 goes into both 3, and 3 also goes into both 6. So 3 goes into 3 one time, 3 goes into 6 two times. Now, x and x squared are also separate terms because they're being multiplied. So those are separate than the numbers in front. X and x squared both have a common factor in them. X goes into x squared x times. Now, if I, and then the answer is 2x. Now, I can just slow it down a little bit and show it to you like I did in problem A. 6 and 3 both share a 3 in common. So I'm going to erase this and start over. 6 is 3 times 2, and x squared is x times x. And then you have a 3 and an x on the bottom. So if you really needed to, you can expand everything down to all its factors and start factoring out, simplifying common factors. So that's what it looks like the long way. Or you can recall from Algebra 1 how to break that just like I did the original first time. And then finally, when we get to C, problem C is a little bit different than problem A and B. Notice that these have negative signs in between them. You cannot break a negative. A subtract sign means that the two terms are connected. So a common mistake is students want to start doing this. This would be wrong. You cannot break apart the 6 and the 12 because that minus sign means the two terms are connected, and you can't break part of a binomial. So how do we do this? Well, again, we're going to do what we did in the part A and B. We need to find or write out the factors. Okay, well, 4x minus 12, you can factor that by GCF. There is a 4 in both terms, so I factor out the 4 and then have x minus 3. The denominator also is a GCF type. There's a 6 in common. So 4 and x minus 3 are factors of the numerator. 6 and x minus 3 are factors of the denominator. Both the numerator and the denominator share an x minus 3 factor. So this whole factor and this whole factor can reduce. Now the 4 and the 6 also have a common factor. 4 and 6 both have a 2 factor in it. Again, I can break it down and say 2 times 2 for 4 and 2 times 3, or you can just simply divide out the 2 out of each term, and then you have 2 over 3. So that whole entire fraction boils down to 2/3. All right, so that is what you did back in Algebra 1. That was the basics, but I want you to get this idea of simplifying as dividing out common factors in the numerator and the denominator. Okay, so a rational expression. I've been using that term, and what does that mean? Rational expression is just a fraction that contains a variable in its denominator. Okay, so 1/2 is not a rational expression, but 1 over x would be. Undefined. Undefined is what we did in problem 1 of the use what you know, and undefined just means it's the x, again, whatever the variable is, it's the x value or values for which there is no value for the rational expression. So if you plug it in, it gives you an error message, basically. And simplifying a fraction means to basically factor or cross off common factors, reduce common factors in the numerator and the denominator. So to divide out common factors that are both in the numerator and denominator. All right, pause it if you need more time to write. All right, problem number 1. For what values of x is x minus 5 over x plus 2 undefined? So if you look below, I have some ways that you can figure this out. Problem method number 1, you can figure out when they're undefined if you set the denominator equal to 0. So Don't care about this, the top. I care about the bottom denominator. I know when x plus 2 equals 0, we're going to have a problem with this fraction because you cannot have a 0 denominator. So you subtract over the 2. So any other number besides negative 2 will be fine, but negative 2 for x will cause a problem. Method number 2. Just to type this in and show you what happens visually and on the table of values. If I were to type in x minus 5, let me go back. Okay, x minus 5 over x plus 2. We could scroll the table, and all of these x's, as long as they have a value with them, they're fine. But once I get to this one, I see that there's a problem. So in the table, if you want to copy that, in the table has limitations because right now the table's going by whole numbers. The spot where it might be bad might be a fraction, so that might be not the best way to go, but you can always take a look at the table. If you find an error in it, that is a place where it means undefined. Now on your Inspire, you actually have the word undefined there instead of the word error. And lastly, graphically, if you were to graph that, I already have the graph for you. If you were to graph it, notice that there's a split of the graph. Okay, anytime the graph splits at a particular value, that means that there's a problem for that x. All right, so this is a problem. Where splits is a problem x. And if you notice, it's splitting at negative 2. So where the split is, that's the place where it's bad. Okay, so we'll try this one more time. Pause it if you need to. Problem number 2. For what values of x is x plus 4 over x squared minus 7x plus 6 undefined? So again, we have our 3 methods. Method 1 is you can remember that when the denominator is 0, that's going to be our problem. So you can solve this quadratic any way you want. Factoring, completing the square, quadratic formula. I'm going to go with factoring if it is possible. Method 2, I can look at the table, and again, this has its limitations. If the answer is a fraction, I won't see it, but you can always give this a try, especially if it's multiple choice. So x plus 4 over x squared minus 7x plus 6. So I see an error at 1. And there's my other error. And they won't always be on the same screen. All right, so you can copy that table. And then where the errors are your problem x's. And then lastly, I already have the equation in the y equals, so I can now press graph, and I can do a visual approach. All right, so if I do a visual approach, where the graph splits means that there is a problem for that particular x value. So I see a problem right here. And again, the table and the graph are just a way to double check your work, because sometimes it might be hard to actually pinpoint what x value this is. But definitely at x equals 1. And then there's another split here. That means there are problem x's for 1 and 6. All right, the last thing you have to know how to do is simplifying, but now we're going to get into a little bit more complicated ones. Problem number A, simplify each of the following. 3x minus 9 over 6x minus 18. All right, we are not doing undefined, so do not set the denominator equal to 0. We want to just simplify this, which basically means to cancel out like factors in the numerator and the denominator. So first, we need to factor. Okay, well, the numerator is a GCF. The denominator is a GCF type. So the numerator, there's a 3. The denominator, there's a 6 in common. So they both have an x minus 3 factor. And then the 3 and the 6 are also separate terms. 3 and 6 both can be divided by 3. 3 goes into 3 one time. 3 goes into 6 two times. And then what happens is you just multiply the leftovers. All we have left is a 1 on top, and we have a 2 left in the denominator. So that whole fraction actually is the same thing as saying 1/2. Part B, x squared plus 6x plus 8 over 16 minus x squared. Again, please don't start trying to cancel out the 8 and the 16. That's a common mistake. You have to think as simplifying as canceling factors. And 16 and 8 are part of a polynomial, so cannot be broken apart. So this is going to be a trinomial, and that is actually a dots. Okay, so the numerator. The numerator has a trinomial beginning with 1. So this type, you want to multiply to make 8 and add up to 6. And that's going to be x plus 2 times x plus 4. The bottom denominator is dots. And if you recall, that means the difference of two perfect squares. 16 is 4 and 4. And x squared is x and x. You put a plus in one and a minus in the other one. Okay, now right now it looks like there's nothing in common. But we have to go back and remember our properties for adding. X plus 4, x plus 4 and 4 plus x kind of look the same. And they actually are. When you add two numbers, adding can be added one way or in the opposite way. For instance, 1 plus 4 is 5, and 4 plus 1 is 5. So when you add in the reverse order, that's the commutative property. The commutative property states that that's exactly the same thing. So adding in either direction is identical. So this and this are common factors. The other two are not at all the same. X plus 2 and 4 minus x are totally different. Those are not like factors. So in the end, your answer is the x plus 2 factor on the numerator and the 4 minus x in the denominator. And that is what the original problem reduces to. Now I'm going to show you a quick trick. This doesn't give you the answer, but at least it'll help you check your answer. If you ever wanted to check your answer, we can do it by testing a number. So you can pick any number you want, let's say 5. You just can't pick a number that'll make it undefined. So no 4 or negative 4. 5 store for x. All right, and now I can just type in my original problem. And I get this value out. Now that's meaningless right now, but if I want to check my answer, x plus 2 over 4 minus x, if this problem gives me the same value, then I know that I did the problem right. And it's a match, so I know I'm right. The only thing this method does not do is actually make sure that you're simplified enough. If you forgot to cross something else off that should have been, it won't tell you that, but at least it'll tell you that you do have a simplified version, maybe not the simplest, but a simplified version of the original. Now, you could have do this on problem A, B, C, or D. I'm going to not do it for the rest, but if you want to, you can always check, like on a quiz or test, your answers that way. So C, all this boils down to is your factoring. C, that's a GCF type of factoring, and this is your harder trinomial that begins with a 2. So we're going to have to do the AC method for that particular problem. So problem C, the numerator, there's a 2 in common. Okay, now the bottom denominator, I may do that work off up here. All right, so I'm going to multiply the A and C number, figure out which factors add up to -5, and I'm going to split that. Okay, then I'm going to do GCF by making my groups. 2x times x minus 3 for the first group. The minus sign comes out. Nothing in common means a 1 comes out. And then it's going to switch. Oh, I'm sorry. That should have been a positive 1. Positive 1 comes out, and then x minus 3. My like terms are x minus 3, so I'll finish it off down here. X minus 3 group comes out, and the 2x plus 1 comes together. So we have an x minus 3 group. Those two are like terms, like factors, excuse me. So I cross those off. And that's it. That's all I can factor out. 2 on the numerator, 2x plus 1 in the denominator. Again, that 2 in the numerator cannot cross off with that 2 down there because that 2 is connected with other terms. So that is your final answer. All right, one last problem. Factoring out the numerator of part D, this is a GCF. There's an x in common, so you're going to factor out the x. The bottom denominator is dots. X squared is x and x. 9 is 3 and 3. Plus and minus. Okay, so now we have to talk about what's happening on this problem. And this is a really important concept, and they test this a lot in their regions. These two kind of look the same, right? They both have the same thing. If you recall back in part B, 4 plus x and x plus 4 were identical. When you subtract, they're not identical. And you can test this out. 3 take away 5 is -2. 5 take away 3 is +2. When you subtract, they create opposite numbers. So when you try to cancel out opposite numbers, they reduce to -1. So this is a huge concept. When it's backward subtraction, they reduce to -1, and you only write it one time. I prefer to put it on the top one, but you can also just put it on the bottom one. But don't put a -1 in both places, because then you'll be actually dividing it out again. So no other things are in common. So big star. Backward subtraction reduces to -1. Now, the numerator now has two things, an x and a -1. It is not takeaway, it is times. So it's going to be x times -1, which is -x. And the denominator just has an x plus 3. All right, and that is your final answer. Okay, so for the only other part of your homework now, I want you to just do the 4 problems at the bottom of that sheet. You can go ahead and pause the video now, try to do the 4 on your own, and then I'm just going to put up the answers and you can check your work. All right, so you can check your answers. Number 1 is undefined when 4x plus 5 equals 0. And then just solve. Okay, so this one would be harder to have checked on your table because that's not a whole number. Number 2 you can actually do on your table. So undefined when. So that would have been easier to do on your table. Problem number 2, or 3, excuse me, you have to simplify. So if you have to simplify, you're going to think factor. All right, the numerator is a dots, and the bottom denominator is the harder trinomial types. Okay, so dots, it's going to be 3x minus 4, 3x plus 4. The bottom denominator, I may want to factor off here to the side. All right, what adds up to 2? It's going to be 6 and negative 4. So my common group is 3x minus 4 and x plus 2. All right, the 3x minus 4 terms cancel, and your final answer is 3x plus 4 over x plus 2. All right, and lastly, problem 4, to simplify, you're going to think factor. That's a GCF, and that's also a GCF. So you can factor out a 4 in the numerator. You can factor out a 2 in the denominator. And then you're like, well, wait a minute, I only see the 4 and the 2 in common. All right, so one other thing you have to know is you're expected to know to factor completely. That guy is actually a dots. So we have to factor this again. So the 2, and then the x squared minus 1 is x plus 1, x minus 1. Okay, so this 2 goes into that 4 2 times, and that's still the only thing we have to do. So that's our answer then. X minus 2 over x plus 1, x minus 1. Had then been able to factor again, we would have had to.